All right, Uglies. This is another installment of Quarantine Calculus, um, also known as calculus where you can see me, but I can't see you, which I think is sort of a win-win. I think everybody's happy with that arrangement. I wanted to talk about geometric series for a little bit. This is uh, it was one of the things on it was the thing on the AP Classroom assignment that I gave you the other day, but it also was in that email that specific topics that were, potentially going to be test items on the AP exam. So this is kind of an easy one to nail down. Some of the more difficult stuff from the sequences and series chapter is not going to be on there, which is good. So if you do get a geometric series question, you don't want to miss it because they're easy. Um, there's just a couple of things that you need to know, and if you know these couple of things, then you could probably would do okay on that whole assignment that I gave you. So let me just recap. And we did this in class, so you actually have notes on this and all that stuff. I just want to do it again, sort of quickly, and maybe I'll say something different this time that'll register with you. So remember what a geometric sequence is. An example of a geometric sequence would be like 1, 3, 9, 27, yada, yada, yada. A geometric sequence is a sequence in which there is a common ratio. In other words, they're multiplying by the same thing each time to go to the next term. So that's a geometric sequence. Now, we don't really care that much about a geometric sequence. This whole chapter that we did was all about convergence and divergence of series. So we're more interested in a geometric series, which would just be the sum of a sequence like that. So let's sort of give kind of a general rule here, and we'll call it S sub n. So the sum of some geometric, sequence for n number of terms. Well, according to what we just said about a geometric sequence, it starts with some number. It has a first term. We generally just call that A. When you're in pre-cal, you probably call it A sub 1. So you can call it A sub 1 if you want to, or just A. But that's the first term. And then every term after that is still the A, but now times whatever that common ratio is. Up here, the common ratio is 3. So the R would be 3. And then when you get to the next term, you just multiply another one. So that's R squared. And then R cubed. And it would just keep going like that until eventually you would have, a sort of a general form for a term. And notice how whatever term number you're on, the exponent on the R is 1 less than that. So like this is the first term, had an exponent of 0. This was the second term, the R had an exponent of 1, and so on. So that would mean that this is n minus 1. Okay, well that's not terribly helpful, but we can use that, and we can sort of derive some stuff from that. So I'm going to do something to this that is perfectly legal, perfectly algebraically legal. I'm going to multiply both sides of this equation by R. So I'm going to make this R times S sub n. And if I multiply R by that side, I would just be distributing an R through the whole thing. And so you can guess what would happen here. That A is now AR. The AR is now AR squared. And basically every term just has one more R being multiplied than it did before. So it would look like that. You'd eventually get to this one, and one more R, if it's R to the n minus 1, would just make it R to the n. All right, well, another perfectly legal algebra move is we can take two equations and we can add or subtract them. This is just like when you learned elimination back in Math 1. So what I'm going to do, I'm going to subtract these two equations. So I'm going to subtract that second equation from the first equation. So S sub n minus R times S sub n. Well, I can't really do anything but just write that down like that. But then look what happens over here. A from the top equation does not have any like terms in the bottom equation. So when I subtract, it's just a minus 0. So it's just a. But then after a, all these other ones, you got ar minus ar squared minus ar squared, ar cubed minus ar cubed. All those would just be canceling. All those would become 0. And you're eventually going to get to ar to the n minus 1, which would actually be the term before ar to the n. So that's going to cancel. And so the only thing that's going to be left is that ar to the n in the second equation. Now remember, we're subtracting it, so it would be minus ar to the n. All right, well now remember this s of n, this is the thing that I want a formula for. So I'm going to factor out s of n. That'll leave me with 1 minus r over here. I'm going to factor out a over here. That would leave me with 1 minus r to the n over here. And then I can just divide both sides by 1 minus r. And I get s sub n equals a. Remember, a is the first term. 1 minus r. Remember, r is the ratio that it's multiplying by each time. Over 1 minus r. So that right there is the general form for a sum of a geometric series. So this is obviously based on a finite number of terms, though. You know, whatever term you want, that would be your n, and you would calculate it from there. But like we said in the beginning, we're more interested in the convergence or divergence of series. And so we're interested in something with an infinite number of terms. And this kind of brings up an important part of geometric series, something that came up a lot on the assignment I gave you, comes up in any free response question that you might run into. If I want to do this for an infinite number of terms, I basically want n to be infinity. So what I want to do is the limit as n approaches infinity of s of n, which of course is just the limit as n approaches infinity of that. This is a times 1 minus r to the n over 1 minus r. All right, well, this brings up an important part about geometric series, like I said. If you're even going to be able to get an infinite sum, then that means that series converges. It cannot diverge. And so if you look at this, what we have here, I can't just go in here and take the limit as n approaches infinity, you know, for any possible scenario dealing with that expression over there. As a matter of fact, this example that I gave up here in the beginning, you know, r would be 3. If r was 3, then if I tried to do the limit as n approaches infinity of, you know, it wouldn't matter what a was, 1 minus 3 to the n over 1 minus 3. Well, that 3 to the n is just going to keep getting bigger and bigger and bigger and bigger and bigger. That would diverge. And so I know you know this, you know, just based on all the other stuff we did, and it sort of stands to reason that the only way this thing is going to converge is if these terms are getting smaller and smaller and smaller. And the only way you're going to keep multiplying something over and over and over and it gets smaller is if that number is less than 1. More specifically, if its absolute value is less than 1. So it can be between -1 and 1. And we said that a long time ago, but it's an important thing to remember, important thing to point out now. So I'm going to calculate this limit as n approaches infinity, but I can only do that if this is true. Well, if this is true, just imagine if r was a half or something like that. Well, you know, if the absolute value of r is less than 1, then as n gets bigger and bigger and bigger and bigger, and I'm just multiplying more r's and more r's and more r's, well, then that's getting smaller. And so that r to the n is actually headed to 0. And if r to the n heads to 0, well, then this is just 1 minus 0, which is 1. 1 times a, which is a. So this limit as n approaches infinity of a times 1 minus r to the n over 1 minus r is just a over 1 minus r. That's what that limit equals. And that is our infinite sum, which is the one that we're kind of interested in this course. So, infinite geometric sum equals A. Remember, A is just the first term, and R is the common ratio, the thing that it's multiplying each time to get to the next term. And remember, the only way you can even do this, the only way this series is going to converge is if that's true. Knowing that equation right there, knowing that formula right there, and remembering that fact right there will get you the answer to most of those questions that I assigned you. I'm going to put some answers up here for you in a different video, but I think that will take you a long way. Email me if you got a question though. That's what we're here. I don't have anything but time. Actually, that's not true. I got a lot of stuff going on, but I don't mind answering your question. All right. I'll have a new assignment up for you soon. Like I said, I'm gonna get you some answers to this. This is actually the second time I've done this video, so if I seem annoyed, it's not me being annoyed with your ugliness as would normally be the case. I'm annoyed because I did this whole video, it got deleted accidentally. I'm doing it again. I would say I did it better this time, but I did it so spectacularly the first time. I don't know that that's even possible. Anyway, enough of that. Email me if you need me. I'll be in touch.